Good afternoon, everyone, and online or colleges. Yeah, welcome to join our session, number 6 session, transformative role of data in SDGs and disaster resilience. Yeah, for disaster, as we know, is very, high risk every year. More emergency weather, extreme weather and emergency response every year. So this is a very important topic, yeah, for data, how big data supports this real field. Yeah. This afternoon, Professor Virigina Marie and me, Juanle Wang from Chinese Academy of Sciences, organize and chair this session together. I will work in the first 1 hour, maybe half hour hosted by Virginia. Yeah, she is a famous scientist for data science and DRR, yeah, in UK, yeah, in the health field. Okay, so first presentation is from Greece. Yeah, Dimitra, Panou. Can you hear us?
Hi everyone.
Okay,
Can
okay.
You hear me?
Yeah. Yeah, you can share your screen and yeah, please start.
Can you see my screen?
Yes, we can.
Okay. Thank you. So, hi everyone. I'm Dimitra Panou from the Demokritos Research Center, and together with Dr. Specht, who is the project coordinator of Climate Adapt for EOS project, we'll present our experiences and our work from Climate Adapt for EOS, a European-funded initiative that focuses on strengthening climate adaptation through open science and fair data. Why I can't go to the next slide? Sorry. Before I begin, I would like to acknowledge and celebrate the first Australians on whose traditional lands we meet, and to pay our respect to the elders past and present. So, in a nutshell, Climate Adapt for EOS stands for fair data and innovative services for magnifying the climate adaptation potential of European communities. The project supports European mission on climate adaptation, and it has started on January of 2025 and has a duration of 48 months. It has 18 European partners and 8 European countries are involved. Our consortium brings together research institutions, data providers, technical partners, universities from across all of Europe, and we have diversity in the team. We combine expertise from climate science, environmental field, ontology, engineering, data management, legal interoperability, AI, everything. And now, continue with the project challenges. One of the biggest challenges in climate adaptation today is not the lack of data, because Europe produces enormous amount of data, of climate data, but the difficulty is in finding, accessing it, and integrating through disciplines. So, climate information is spread through different data sources, different data spaces, such as Copernicus, GeoS, Climate Adapt, and also we have more local data spaces, national data spaces, from even in institutional level data spaces. So, the goal of Climate Adapt for EOS is to integrate these different diverse climate data spaces into the European Open Science Cloud, creating a unified digital ecosystem for open, fair, and interoperable data sharing across Europe. So the goal is not just to share data, but to have transparency and to work with them as well in decision making. Now, as I said, we focus on to have fair data, to be findable, accessible, interoperable, and reusable, and supports European mission on climate adaptation, which aims by 2030, all Europeans have access to reliable information on climate risks, and 150 communities and regions to develop resilience and risk management plans. This mission addresses cross-domain collaboration, so combining efforts from civil society, local authorities, environmental field, science and data providers. Climate data for EOS provides the open data backbones that allows this collaboration to happen effectively. Now, to achieve this, our work focuses on 6 major pillars, we can say pillars, to identify user and stakeholder needs for climate data. Here I want to mention that we focus on local stakeholders, to create a local stakeholder community. Also, developing fair data infrastructure called Climate Adapt Data for EOS, ensuring that data are findable, accessible, interoperable and reusable. Establishing interoperability framework across technical, semantic, organizational and legal levels. Creating a suite of analytics and modeling of services, the Climate Adapt service for EOS. Using these tools to demonstrate through real-world use cases and ensuring that these are aligned with EOS and European adaptation mission. So, together these actions lay the foundation for a connected, fair adaptation ecosystem. Our approach combines data management, methodology engineering, and cross-domain interoperability under the same umbrella. On its core, we have developed a knowledge graph that links datasets and metadata across disciplines. And to ensure that this process is successful, we have designed interoperability frameworks in 5 levels: technical for data integration and exchange, a semantic for vocabulary alignment and ontologies across domain, an organizational and a legal for compliance sharing. Now, to demonstrate the values of fair and interoperable data, we have developed 4 innovative climate services. 3 of them are applying to 3 main use cases and 8 replication sites across in 5 European countries. We have in France, Greece, Portugal, Cyprus and Poland. Now, the first use case, the first service, is Just Cares, a digital twin for just climate, urban resilience that helps design adaptation strategies for socially vulnerable communities. As a case study, we have a region, a municipality in Greece, Galeo, that suffers from extreme heat up to 45 degrees. And we have as replicators 3 regions that suffer from have the same problems, suffer from similar problems. So we have Aveiro port of Portugal and West Athens in Greece and Strovolos in Cyprus. This digital twin has many sub-services like for socially vulnerable communities containing, for example, some community resilience indicators, energy poverty, heat climate risk assessment, and many others. Now continuing to the second service, the OpenHydra is an application that supports adaptation in coastal regions, assessing sea level rise and coastal hazards. It is, as a use case, we have Central region and contains 2 other applications, Open Coast and Hydra Alert, to boost the region's resilience to coastal hazards. We have 3 replicators also here. The port of Piraeus in Greece, the port of Rhodos in Greece, and the port of Dunkirk in France. And the third use case is 3SES, Ring Swell from Space to Earth Service, that uses satellite data to map soil expansion and contraction risk in threatened infrastructures. It is tested in 3 French regions in different climate patterns and uses satellite and complementary datasets. Also, we have 2 replicators here, Rhodos Port and industrial region in Poland. And continue with the 4th service, BDA Analytics, is a big data analytics platform for comprehensive climate risk assessment. So all these 4 services transform fair data into actionable tools for decision makers, researchers, and local authorities. Now, if you want to support our project, you can join our stakeholder forum. We have created the stakeholder forum in this link. You can access it. And also, if you want more information about the project, you can contact me or the project, and of course visit our social channels. Thank you very much. If you have any questions, I'm happy to answer.
Okay, thank you, Dimitra. Any comments or questions? Okay, if no, maybe we have the second part, maybe have the discussion. Okay, thank you. Okay, so welcome next speaker, Virginia. Her presentation is about
Thank you so much.
So have a book?
Yes.
Okay.
No, I'm just going to share it just in case people believe we haven't done the work. So it's a great privilege to be here to have this opportunity to share with you a fairer hazard information profiles, which is about implementation and novel uses of the UNDRR International Science Council Hazard Information Profiles. It's a huge privilege to be with you all. You will all remember that in 2015 we had the great opportunity to work with the United Nations and all the UN member states who agreed 3 incredible landmark agreements of the Sendai Framework for Disaster Risk Reduction, the Paris Agreement and the SDGs. And they all marched together, which is why this session is so incredibly useful and important here. So huge thanks to you, Professor. Very good of you. The Sendai Framework is a thin framework of 50 paragraphs. But what it does in it is to really bring together a global outcome, 13 guiding principles, 4 priorities for action, and 7 global targets, which you can see about reducing mortality, morbidity, economic loss, and damage to critical infrastructure, particularly health and education. And it calls for every country to increase its understanding of its hazards, but also to have international cooperation and early warning for all, which I'll mention again shortly. The whole purpose of it was that one of the great successes of the framework that was agreed in 2015 was that these should be reported, these targets and indicators. And the Sendai Framework target and indicator system is there. But when in 2018 it was reviewed, many of the countries found it really difficult to report on these hazards. So we went back to the Sendai Framework, and in paragraph 24J, it called for strengthening technical and scientific capacity to assess disaster risks, vulnerabilities, and exposure to all hazards. I said that it was possibly quite important for us to review this, and I somehow ended up by being the chair of a working group. Very careless of me, so forgive me. But we managed to publish in July 2020 a huge review of every single global list that we could find in the UN and in the science community of all the different hazards that we could find, and we published that with a lot of the guidance on what we were doing, and then we went on to publish the hazard information profiles in October 2021. We could only do this because we had incredible participation with over 40 different UN agencies and organizations who were just fantastic. also the International Science Council, and in this forum of the International Data Week, it's really important to highlight, of course, CODATA. We had a lot of support from the industry, particularly through the Insurance Development Forum, which is really key to trying to build the reinsurance industry. But I can't do anything without people. And we were really lucky that the International Federation of the Red Cross, Red Crescent came in to be the international humanitarian organization, and they have been very good friends the whole way through. But then we had lots of volunteers, and we reached out to many. And that first reports that came through in 2020 and 2021 were reviewed by the midterm review of the Sendai framework, and we were very delighted to see it was described as groundbreaking. So huge, thank you for the smile. Thank you very much. We were pretty excited too. It was really nice to be told we'd done something useful. But we were also linking it to Antonio Guterres' call for early warning for all, which came out on the 23rd of March 2022, which I was privileged to speak at as well. But now, even more important, is the Sendai Framework Disaster Losses and Damage Tracking System, which is absolutely key, the new Delta system, which has at its heart our hazards. Absolutely fantastic. But of course, one of the consequences of doing something that needs updating is you have to update it. Very difficult. So again, thanks to the International Science Council, Vanessa, it was amazing having your support. And thank you for funding the wonderful project manager we had with us, Hélène Jacob-Decombe, who was just phenomenal in helping us to deliver something that was really pretty complicated. We did user surveys, and we were really excited to hear how much the hazards had really helped many people at many levels. A lot of people responded that I never heard of and didn't know, and they were really good. So I'm really pleased to say that we have now launched these Hazard Information Profiles Update 2025 in August. It was really exciting to do that. And there's a QR code, and I'm happy to share it all with you. And you can see that it's a little light tome. So what we have now is 281 globally agreed hazards. So we have a lot of the hydrometeorological, extraterrestrial, chemical, biological, technological, and David, I know, will be talking a little bit about the cyber hazards. And of course, we have the environmental hazards. And Julie will be talking about coral bleaching, and we've just been checking those out too. So I love the fact people are interested in the hazards. Of course, we have the geological ones, many of which are really important for New Zealand. So really important to think about, and we've reflected many of the discussions there. But for completeness, we were allowed to include societal hazards, which of course conflict, post-conflict, environmental degradation, civil unrest, violence, stampedes, and other things that I think are really important, including financial shock. So I thought I'd show you one, just to see what it looks like. Flooding. So this is a chapeau hazard. So the whole thing is that if WMO cheerfully said, oh, there are well over 70 different types of flooding, and we didn't want 70 different types of flood hazards. So we're down to 12 inside this, but it really works quite well because you get a definition that is agreed from WMO, the highest UN organization we can with UNESCO. And we have things like what are the drivers of the hazards. We get health information, economic information in this hazard, but we also get something on the multi-hazard context, which is too hard to read, but I'll show you in a second. But quite a lot on monitoring and forecasting what the hazard might be, so people can understand how they fit in with the early warning for all program. And a little bit on risk management, like don't build in the floodplain, please, but put more politely than that. And then, of course, we have the references, which are open access, and the final bit is to have who owns it, which this occasion is the World Meteorological Organization, who have been very good at picking up these. But the multi-hazard context is very much the new bit of the hazard information profiles. And you'll see above flooding is the parent of the floods. So what causes flooding in our hazards list? And then you go down below, so the children of a flood. And you can see how it works together. And we hope this is really useful in trying to inspire people to look at the consequences of these events. Now, not all of them may happen at once, but there are a lot of things that I think are quite important to share. So in the technical logical drivers of flooding, you have the fact that reservoirs fail, dams fail, and of course we have all the storms that have been happening around the world really very recently. But also you get the geological impacts, you get the technological impacts, and in the biological impacts, flooding is unfortunately renowned for causing things like increased snake bites, because they swim, these snakes, and they can get people. And I don't think people are aware of that, and there were some really interesting reports from India on this. And of course, the other thing is that a lot of the explosive ordnance floats. And in the Black Sea, a couple of people were killed recently for swimming in the Black Sea with some explosive ordnance. But let me show you space debris. This is a new hazard, very much requested by our wonderful UN environmental program, a chief scientist. She was really worried about it. It is something that's being regarded widely. Earthquakes, of course, are unbelievably important. Loss of mangroves. I'm thrilled with the input we've had from so many of the environmental concerns. And loss of mangroves is difficult to explain because it doesn't have a UN definition. Corrosive substances, very important to try and explain about these terrible acid and bleach attacks and other issues that occur, and it's really important that we have that. Foodborne diseases, this is another chapeau which includes all the different causes of foodborne diseases. Building collapse. Yes, important, it's been happening again, and of course environmental degradation from conflict. So what's new that we're trying to do about this? Well, the best thing is that it's been this incredible collaboration of about 500 experts from around the world, be they members of the various groups that have been supporting it, the contributors, the reviewers, the incredible networks. But what we've tried to do is to make it scientifically robust, but most importantly, user-friendly, something people can access. But what we really hope that is really exciting that's happening at the moment is that there is a machine actionability working group, which CoData is very much part of, along with some other fantastic colleagues. And the whole purpose is to have the encoding of the terminologies in line with the FAIR principles, but to make translations easier, possibly even into the 7,000 languages that people have. It's likely that Chinese will be the first language we'll try. So it's really exciting. And we need to facilitate AI usage so that AI uses it a lot. None of this could have happened without the incredible network of wonderful friends and colleagues who are so skilled, who volunteered to do a lot of this work. We shared it at the global platform, but in summary, FAIR Hazard Information Principles take you from Sendai Framework, the SDGs, the Paris Agreement, all the way through to these hazards, but how we can actually document the loss and damage. So one day, perhaps we'll do better at managing these events. Thank you.
Thank you. Yeah. Do you have any comment or question currently? Yeah. Yeah. Please.
I'm Alison Specht, so very pleased to know. Just a personal exercise. Oh, sorry. Just a personal question about you being here in Brisbane on the east coast of Australia. I hope you are seeing and learning about some of the hazard illustrations we have here. For example, Brisbane is a very bad flood area. Dams broke in many years ago, yes. But was one illustration. And there's some interesting risk assessment work and work has been done on drought and floods. You didn't have drought.
Of course it's there.
Yeah.
Absolutely.
Oh, good.
No, that didn't escape.
So,
desertification, all these things are there, and of course wildfires, which are bushfires here. But if I mention to you, I've been to Lismore.
Oh, well, I lived in Lismore for 26 years, and I've written on in chapters in books on disasters.
So we'll talk about it later.
Oh, fantastic, good.
I've been doing a lot of it, and of course coral bleaching.
And coral bleaching, but that's good. I'm so pleased you are making the most of your visit. Again.
Oh, yes.
Okay, thank you for the question.
Thank you.
So let's continue. Maybe Najila Wolfla is not here, I think. So we move to the next. Alison Specht. Oh, okay. Okay. Thank you. It's okay. You can. Yeah.
Okay. I think it's going to work. This is something completely different, so I'm not quite sure. I could have done something on extreme natural events, which I did many years ago, particularly after the Indian Ocean tsunami. But I'm talking today about a paper. In fact, it's based on a paper, and you'll see at the bottom a little DOI that these co-authors, I wrote with these co-authors, where we put together some expertise from different areas, so multidisciplinary, as is my wont, approach to putting forward a presentation about how you might develop a collaborative data network for the Asia-Oceania region. And this was stimulated by a CODATA special issue, with which we were loosely involved through Murayama-san from Japan. One of the co-authors is here, Professor Pedro Correa from Brazil, so very pleasing indeed. And so I shall proceed. And we're very, very pleased to have the opportunity to talk about this particular paper at SciDataCon in particular, because it is multinational. First, I'd like to acknowledge and celebrate the first Australians on whose traditional lands we stand, and here is the Turrbal and Jagera people from the broader Brisbane area, and of course Brisbane, the place, Brisbane didn't exist as a city at all, is Meanjin, and it's very, very significant. But the challenge we had, a couple of us had been thinking of for many years, was how best to enable local communities control the management and discovery of information about their own assets. So this was something I and the second co-author, Kim Bryson from the University of Queensland, had talked about in France many years ago, that many of these local communities, particularly in the southeast, the Pacific region, the South Pacific region that we had both worked in some shape or form, really were suffering data loss, information loss, and really didn't have the capacity to redress that. We thought that was the case. We found we were a little bit incorrect in that, and you'll hear about that in a minute. But the idea was that we would think about how they might adhere to fair and care principles, how we could help that happen, enable that to happen, and of course enable them to have that sort of repository resource that would be robust, sustainable, and compliant with the trust principle. So it's owned, people would own their information and preserve it in the first instance, but of course have a tradition of being used. So as I mentioned, there is a brief link to the paper. Published at the beginning of this year. It was the first week of the new year. It was great. Anyway, so we devised something called the CREDAN, the Collaborative Regional Data Access Network. The two principles were to have an appropriate structure, which included engagement, with country-level centralised databases and repositories. So this is a brief summary of the CREDAN, and it would be a distributed network with a collaborative coordinating authority. Now, I will describe how that was achieved in a minute, but this is kind of the outline that we could put at the end if we wanted to. And the second component, which is where I mentioned we brought in some different ideas, was that might not normally come together, was the use of enabling technologies. This modern new idea that some of these modern new ideas that we may have, we hear a lot about AI, for example, but how might we use them best to ensure the fidelity of provenance, licensing and protocols to be pulled together? And we discovered, Kim Bryson and I, or at least I did initially, were that, in fact, the memories of countries not being quite aware or quite enabled, that, in fact, the Pacific Environmental Data Program, and the Pacific Environmental Data Portal in particular, and 2 representatives are here at this meeting, Tavita Swa and Lagi Rupina, so please say hello to them, was established and did exist. So we were quite inspired by what they had done. So we're not building on nothing. We know that the core principles are already in place. So our vision was to have country or sub-country level centralised databases and repositories. Now, we did focus on the South Pacific Island nations, and you may know that Tuvalu is due to be abandoned because of sea level rise, literally abandoned. The population is being prepared to be hosted here, for example, in Australia. So these particular countries have faced up to their challenges. There's also been a history of collaboration post the Second World War, which was actually quite helpful because there was a structure. And now the International Science Council has an academy of science based in this area. So we didn't look at a model for our CRIDAN as being in Indonesia or in the Philippines. Papua New Guinea is included, but not West Irian, for example. So anyway, so that's kind of where we started the scenario, again inspired by this South Pacific Environmental Portal or program. They're kind of nested one in the other. So the first step would be to help the community get involved. And there was our second inspiration, or at least my second inspiration. I was captured by something that you may have already heard of when people talk about care. Care is actually a nice set of principles, but practically often, it's still emerging as emergent technology in the way it is enactable. And I was captured by this idea of the local context labels that has been developed by a group of people, particularly in New Zealand. And you've got the link to that. It's developing as a concept quite rapidly. So where we saw it last year is different from where you see it now. But that's very encouraging. So a lot of this, if you've got the bright minds and the will, it's amazing what you can achieve. But the idea was that using those local context labels and using community engagement and discussion, and you'll see here we had communities, and I think I can point, yes I can, communities there and individuals, and you may organise a country in this way. In Australia we use catchments as an organisational group around a river system, something like that. But it could be anything. We've said country or sub-country level centralised databases or repositories where people are encouraged to identify and save and record their digital assets. In the case of the SPREP, several partner countries have developed small repositories owned by them. Whether they are actually doing the labelling that we're suggesting is another matter. And the labelling enables them to set conditions for sharing with others. This is stuff that we want to keep, we don't want to lose, but we don't want to share, versus this is stuff that if you consult with us and we agree that you can have it, we can share it. This is stuff we want to sell. And of course, a lot of this comes from food, trade, as well as natural assets and heritage assets. Of course, in our case, quite often in our scenario that I mentioned, many of these small organised groups don't have the individual capacity, funding, whatever you might call it. They might have the will, but they don't necessarily have the capacity or the funding. So we propose that a distributed network with a collaborating, coordinating authority would be the way to go to develop. Now, in the case of the SPREP, there's a centralised repository. So those of you who know the difference between data lakes and federated data systems, this proposal is slightly different and is quite important and somewhat, the idea is democratic. It is, there's a governing board at the SPREP and that sort of thing. This would be similar to that, but it would enable people to share the load, share expertise across the group, share support and backup, highly prevalent. Wasn't really thought much of in 2024 when we were writing the paper, but has come up even more strongly now with the changes in the USA. We should always have been doing it. Share costs. One mob has enough funding to do X, the other mob doesn't. Maybe they could share that sort of cost. And by being in a distributed network, that can happen more easily. And facilitate, if you were at our session this morning, you would have heard from our SPREP representative that one of the major drivers for them having got as far as they did is because of the international pressure to provide reports. To report, the Pacific Island nations, for example, presented their material to the IPCC in Paris way back in 2015. En masse. They had to do that. They had to have a case. They had to get their act together. And this is a way to make that act easier to obtain every year. So there we go. That's the bit. Now, enabling technologies. Where do they fit in? So we had a look around, and we happened to have some expertise, namely in Shufen Chow, who was a PhD or postdoc at the University of Queensland, who was an expert in blockchain and worked in food systems for transport of food across the world. So he was really good at blockchain. He didn't quite understand, may I say, he's not here in the room, sorry, how we wanted to use it, but then, not initially, but then we got it. And one of the things, there were 4 things that really was attractive about the blockchain. One was that you could anchor your digital objects to a blockchain that ensured their immutability. I'm assuming I've got a little bit longer, so I'm not watching on the clock, but I will be quick. Linking digital objects to a blockchain thank you, to ensure its immutability. That proof of the data availability, now this may be purely internal, just remember that, but you can actually say, yeah, I did deposit this data. This object does exist. Now, it may be information about a physical object, or it could be a digital object, but it's still digital by itself. And of course, you can label and attach your blockchain hashtag with access control. Remember those local context labels? You can turn them into a blockchain tag that would be really labeled, really permanently and immutably attached to the blockchain object itself. And then, of course, auditing and compliance. So those 4 things, you can read more about it in the paper, not that much, we're still fairly limited, really was quite attractive. Then a new item came on scene that has been sponsored by the WC3 group, the decentralised identifiers, because you can begin to get the identities of the suppliers and the users attached so that you can bring them into the blockchain, and it's a really emerging technology, but we think that could be a useful component in the CRIDAN, the network we're suggesting. And of course, smart contracts are a little bit more established, and they are really useful. You talk about licensing, that's, as we should all talk about licensing, this actually adds even more persistence and registration of who owns and what are the terms and conditions. So they double up on the label on the hashtag. Okay, so putting the pieces together is where we are with CRIDAN. So we started with the importance of sovereignty and ownership at the community level, be it within a catchment, if you're in Australia, or a tribal group, a mob, as we call them here, or a community group, a river system, or a whole country, or a state. That wherever that decision is made, you can still use blockchain, but it's off-chain. You can still use many of the aspects of blockchain, namely you can put a hashtag on every object that you have identified in your data hub. You have a data hub, you describe your data, you then apply your local context label, you turn that into a hash value, you have an off-chain reference, and you determine those access rights. Those data owners determine the access rights. So you can see there, the data owners. I love having a laser pointer. But then, once you've done that, you then can open it up to a certain, to a wider degree, to a wider audience, depending again on those labels. So you can turn it into an on-chain data management. Some of it may still remain in-country, as we say, but some of it can be brought with the smart contracts that have to be facilitated by this governance group that you remember in the Collaborative Data Network was encircling it. So that particular group would enable these individual data hubs to become, not individually, unless when they can be discovered individually, but they can have the help of the whole group to develop a hash and off-chain reference registration, to develop their smart contracts. You'd have to have some expertise in this, not centralised but similar centralised organising group. So it would need funding. We always need funding. And that would predefine and grant user access. Then you could open up, and I didn't quite have the hiding boxes, but then you would open up the on-chain data management organisation, which you do in number 2 there in that diagram, through to user access, number 3, with the permissions as set in 1, carried through into 2 in these smart contracts, and of course the access then becomes with data users, data owners, through to the DID. So that's the CRIDAN, and you can see that organisational group that sponsors it, and if we think of the South Pacific, small South Pacific island group, you've got to 32 different islands. They would get together, maybe not all of them at any one time, but a core group would get together and determine, would oversight on whether the data were fair, whether everything was fair, whether the sovereignty was being protected, and ensure that there was some good data security, stewardship, and provenance was all fed through in this fashion. So that's the idea. So the first step, so we've been hearing quite a lot about, yes, 1 minute. This was the last slide. We've been hearing quite a lot about the need to include people and humans in many systems that we have computerised or automated, be it AI or other sorts of modelling facilities, for example, or tools that we use. And these first 4 really are fundamental. So they can take a long time, mind you. We're not suggesting it can't, but if you've got the common intent, as, for example, we discovered the South Pacific Regional Environmental Portal had already developed. They don't necessarily have everything, but they certainly have common intent. Common standards and protocols to be agreed with the group, collect and store data, so they have got some data to share. And then, once you've got your community determination, you can apply your blockchain hashtags, expose holdings and their hashtags. It may only be like metadata holdings, or you may have the whole data set available, and then the data owners make sure they've got their unique DIDs to track data use. So that's the idea, and I'd like to thank you very much for your attention. Great.
Thank you.
It's a pleasure. I'll move it on to the next one. There we go. That's good.
Because time limited, okay, we go ahead for next speaker. If we have time, finally, we can discuss. Okay. Next one is our presentation about marine knowledge value chain. Yeah, provided by Chiara, Altobelli. Okay. Cannot open. Maybe link is not available, so you can. Is it yours?
Yep.
Yeah.
I can see that. Okay. Hello, everyone. I'm Chiara Altobelli from Italy, from the National Institute of oceanography and applied geophysics. I will start with the bad news for the chair. I'm not sure I can contain and refrain my enthusiasm to be here with you and share what I'm about to say, because it's not just about a project, it's about, okay, let's start with the acknowledging of the traditional owners of the land that we are meeting on today, for sure. And then I will start talking about the European Marine Observation and Data Network. But not just because I want to talk about the project, because it's not just about a project, my presentation, but it's about a well-structured data management system can help policy to guarantee the human beings a future. Not just an elite of human beings, but most of the human beings. Why I'm saying this? Okay, let's start with a very short overview of the European Marine Observation and Data Network. EMODNet offers services to share data on marine in situ data, but most of all, it's a network of passionate organizations, more than 120 organizations that gather marine data and make them freely available to everyone, thanks to a portal. So we have, but sorry, I want to just briefly say about this. Okay. Sorry. First is, we collect data on 7 thematisms that are bathymetry, biology, chemistry, geology, human activities, physics, and seabed habitats. And all of these thematisms has built up a specific network of organizations, research and monitoring as organizations, national data centers. This is a European-funded project, a long-term project, funded since 2009, and with a vision to 2035. My institution is in charge of the EMODNet chemistry lot that provide data on eutrophication, oceanidification, contaminants, and marine litter. And this is the network that includes 66 organizations, national oceanographic data centers, research institutes, monitoring agencies, and international organizations, plus a board of experts on the EU Marine Strategy Framework Directive, that is a pillar in Europe to protect the environment, and marine and ocean in Europe. And the main goal of EMODNet is just supporting the implementation of this directive. This is a very complex infographic that I will try to make it simple for you. It is the marine knowledge value chain in Europe, from data to knowledge. The first step is the data collector in the field at local, regional, and national level. They are research and monitoring organizations collecting data in the field. Then we have the data stewards at national level. They work mainly for national oceanographic data centers, and they are in charge of aggregating, standardizing, and validating the data coming from the data collectors. And then we have the role played by EMODNet. EMODNet partnership is one of the blue data management infrastructure at European level, like Copernicus Marine Service for satellite data. And then we have the blue data management infrastructure at global level, and EMODNet partnerships collaborate with this blue data management infrastructure at global level, like, for example, the Europe Global Partnership on Plastic Pollution and Marine Litter. And obviously, the last chain, the last link is the last link of the chain are the final data users of the data that are academia, blue economy, policymakers, and public authorities. In this slide, I tried to simplify the EMODNet chemistry workflow, split it into 5 steps, and they're responsible for these tasks. We have the data originators that provide data from monitoring research, industry, and citizen science. Then we have the network of data stewards that gather and validate data at national level. The regional coordinators, where region means specific European sea basin, for example, Baltic Sea, Mediterranean Sea, Black Sea, etc. The regional coordinators are in charge of standardizing and validating data at regional level. And then we have regional coordinators plus data scientists that produce and publish quality data and related maps, and scientific communicators and data scientists that liaise with main stakeholders. This is e-modern chemistry, main task and responsibilities. I will just show you briefly the e-modern chemistry services that are obviously a data discovery and access service, a products catalog, a map viewer, and a data explorer and extractor service. But I want to go further, because what I really mean is the use that is done of e-modern chemistry from data originators and data users. These are a list of the main data originators. Of course, there is the e-modern chemistry partnerships, as I said before, 66 organizations that work together to gather data from data originators. Then we have the International Council for the Exploration of the Sea, European Regional Sea Convention that provide data to e-modern chemistry and share data with us, Research Institute, Monitoring Agency from EU member states, Copernicus Marine Service, and obviously also we have data from citizen scientists. I will just show you some example of use of e-modern chemistry from data originators. Here we have the e-modern chemistry partnership providing data from all around Europe. This is a specific database maintained by ISS, the International Council for the Exploration of the Sea, and this database, the data from this database flow to e-modern chemistry. So we have in contact with ISIS, and we have this workflow set that provide data from ISIS to e-modern chemistry, and the data regards seafloor litter from trawlings. And this is a case of data from Regional Sea Convention, in particular the ELCON Sea Convention. The members that signed this convention that borders the Baltic Sea provide the data on beach litter. And these data are collected under the Marine Strategy Framework Monitoring Program. e-modern chemist is in charge of managing this data, aggregating them and validate them, and make them accessible through the platform. And then the ELCON Commission use this data for their regular assessment report on the state of the Baltic Sea. And lastly, we have also the Volvo Ocean Race. This is an example of a citizen scientist on board of this sailing boat, then through very easy and low-cost technology can collect data on microplastics and make them accessible through e-modern chemistry. These are the use of e-modern chemistry from data users. Data users accessing our platform can download data and use there for multiple purposes. Some example of data user are the European Environment Agency, European Commission Joint Research Center, Copernicus Marine Service, Research Institutes, EU projects, and European Digital Twin of the Ocean and Global Data System. Some example, okay, ISIS and e-modern chemistry put together their data and provide them to the European Environment Agency for their regular assessment report. We have plenty of examples of use of e-modern chemistry data from the European Commission Joint Research Center to implement the Marine Strategy Framework Directive. Copernicus Marine Service also use in situ data for producing and computing the maps. Research institutes, plenty of examples. We have eutrophication climatology to decipher the consequences of climate change in the Adriatic Sea. We have the first marine litter assessment tool. Another example is an integrative tool for the assessment of eutrophication status at the submersive level in the Mediterranean region. So all these examples start from data downloaded by Chemistry portal. I want to just spend some words on the Chemistry and Copernicus Marine Services provide the data backbone for the European digital twin of the ocean. And at global, more and more global data systems are asking Chemistry to share the data and to be part of global data system. Okay, this is to show you how data can really speed up the process of adopting policy for guaranteeing a future of the human being. We developed the first marine beach litter database in 2018. 2018, first database. Then the year after, the JRC produced and was able to compute the first, define the first beach litter baselines. This brings to the first adoption, the adoption of the European directive to reduce the single-use plastics. And then we have the definition of the threshold values for beach litter, and so on until yesterday particularly, 2024, was released the first European coastline marine litter trend, and it's states on the European coastline single-use plastics reduced by 40%. In a very short period from 2015 to 2021. So let's see how brief is the path from establishing a well-structured data management system from having this brilliant result. I want to conclude with a call to action for improving the European marine knowledge value chain. For the ocean mission, a call to action for strengthening the link between data stewardship and both research and monitoring program to improve the availability of fair data. And for the climate mission, I called to action for improving societal preparedness because although national database climate risk assessment are increasingly used to establish adaptation policy implementation is lagging behind, quickly increasing risk levels. So we have plenty of policy, but we should implement them. And then I want to finish with a call to action for improving the global marine knowledge value chain. For the climate mission at global level, I would ask for a call to action for improving the dialogue between science and governance, because policymakers can't ignore anymore that scientific understandings underpin the key findings, which are statements of facts about current status and trends, current and future risks. Human activities are responsible for climate change, and we also know that what has to be done in the short and long-term period. And the last call to action is for implementing mitigation and adaptation measures that are urgently needed, but there's no sense of urgency at all. Look at us. There are 4 people in this room, almost empty. I'm really disappointed. I wanted to cry, but we need to do something to make these rooms full of people interested with the high sense of urgency, because the no sense of urgency is leading to insufficient resources and political commitment to support research, low emission technologies, and climate literacy. And it's also leading to public and private financial flows for fossil fuels are still greater than those for climate change adaptation and mitigation. And this is not me that I'm saying these things, but is the UN Intergovernmental Panel on Climate Change 2023 report. So I would ask to all of you to join our efforts, and I invited Juliette to stay with us, because marine scientists can do this alone. We need the social and human scientists to support us, to set strategies, to make aware policymakers of the urgence of effective actions on this topic. And we can't wait longer.
Thank you so much for the ocean and the chemistry and other data collection and sharing in Europe. Yeah, it's very important to adapt to the climate change. Yeah, our next speaker will also related to this issue for the ocean. Conservation. Okay. Yeah, it's true. The audience is limited, but I think some people still online. So, as I mentioned before, yeah, with Virginia, I have a presentation next room, yeah, conflict. So I will introduce the next two speakers together, and after their introduction, Virginia will organize the discussion, maybe. Okay. So next one is Julia. Yeah, her presentation is from data to action, supporting coral reef conservation in the Pacific. And last one is David Gao. The presentation is regular respond and rectify, review, and governance the technologies beyond cyber crime attribution. Yeah, very interesting. Yeah, please. Close this one. Here.
Thank you. Can you see? Hi everyone, and thank you for being here. I think I can going after you and talking in terms of sense of urgency, talking about coral reef. It's pretty. We have the right order, and you cannot be here in Australia and not hearing about coral reef. And I'm a research scientist at the Australian Institute of Marine Science, and I'm going to talk about a project that is called Reef Cloud, and how Reef Cloud tried to support the coral reef conservations in the Pacific, but also around the world. And that's a project in collaborations with QUT, the Center for Data Science, where there is the booth in the main hall. And talking about urgency then, sorry, I just start with to acknowledge the traditional custodians and first people of the land we meet here, and I pay my respect to the elder past, present, and futures. So about the coral reef, and yeah, my talk is a bit different. There is a lot of nice pictures, of course. And so coral reef conservations, like coral reef is one of the most vulnerable marine ecosystems of the world and highly impacted by climate change. But one of the main challenges that we have is to understand the impact of climate change, to be able to manage the reef. And the issue is there is no data. So here in Australia, we've really massive outliers around the Pacific. We have a lot of data. But as soon as you get out of Australia, there is really few monitoring data. Most of the programs, they are sparse and fragmented. And so that means that it gets really difficult to manage some things if we can't measure it. And this is because monitoring the reef is really expensive. And also, when there is data, there is so many things that we can monitor on the reef, a lot of different methods, that putting all this data together, it's just not possible. When there is data, most of the time we cannot access it, just because either the data are in the hard drive of a marine biologist, or for some countries around the Pacific, the monitoring data are not allowed to be shared. And I think that's a bit of the history of what we like to call science colonizations. Used to have like the scientists going in the Pacific countries, collecting data, going back home, publishing about the data, and that's what it. Nothing came back to these local communities. In some countries, they had to say, stop about it. So they can't, that's what you were saying, you were talking as well. And so the data access are limited, and also like there is some unequal capabilities of monitoring effort. And the fact that the reef data are pretty complex. We talk about the most biodiverse ecosystem of the world, highly impacted by disturbances. And so because of these challenges now, that means that we have a delay of informations to be able to inform decisions-making processes. And so that's why we developed Reef Cloud, to try to face these challenges. So Reef Cloud is a digital platforms where everything is based on images from the seafloor. So with Reef Cloud, we're mostly interested about the species that grow on the floor, on the seafloor, like for example, like the hard corals, which are the habitat species for the coral reef. And so Reef Cloud is 3 main components, where the first component is a cloud-based computing to manage and store the photo data. The second component is the machine learning algorithm to analyze these images, so to automatically classify the different biodiversity from the images. And the third component, so that component creates the data, and the third component analyzes the data. And then we package all the knowledge into reports. That's going back to the people who is giving us the images. And so by being able to create this secure repository for monitoring data, that opens us a door to collaborate with various organizations. Organizations like community groups, like some fishermen now in the Pacific, they go fishing, but they can also take images as well, and they upload them with Reef Cloud. We collaborate with the reef scientists, some indigenous scientists, and also like with some tourism industry, where they use the Reef Cloud to follow the changes of restoration actions, for example, how the corals grow when they do some restorations. And here that's an example of collaborations with indigenous scientists, so where we collaborate with sea rangers in country in Bardi Jawi. So Bardi Jawi is located on the northwest of Australia. And we have these unique collaborations with the rangers where we give them the technology to go and take images. And they go and take images where they want and when they want. And then the images come back to Reef Cloud. We analyze them, and then we produce something that is useful for them to understand the changes of the marine biodiversity. So here that's an example like that we do with fish. So we don't give them the distributions. We just give them the color code. And that's depending of the colors, it says that if the change is positive or if the change is negative or if nothing has changed. And they get this information and then go back to the community to tell them that, well, how well the sea country is doing. And so then we created the platforms to be able to give access to some robust machine learning workflow. So that's a kind of what you see when you are using Reef Cloud. So that's completely private. So people, for example, I don't have, yeah. So people once you upload your images, then you can see where I am. Can you hear me? Yeah. People, when you upload the images, then you can see where the images are located on the map. And then you have information about the machine learning, so that's mostly like the manual trainings, and also if the models has classify all the images, and so this kind of metrics. We also provide some information of how good is the model, and so we know that the people using ReefCloud are not experts, but they have to be the one to assess if their data are reliable or not. So that's this kind of metrics, like for example this one with a lot of text, a text that everyone can understand. What we hope is that people understand a bit more and judge if their data are good or if they need to go back and train more, like the machine learning model, for example. And so you see also like you have the export data tab. So at this point, the user, they have two choices. They can keep their data private, so they export their data and they do the analysis. We also have like a small report with some small data analysis and data visualizations for the people, then they can get and put into their reporting. Or the people decide to put like the data public. So that means that we, in the back end of the ReefCloud, we are using all this data to make some modeling and to understand the changes in space and times across like global scales. And so that's the ReefCloud, the platform, help us then to integrate different data sources. And so that's one of the latest assessments. That's the monitoring locations across the Pacific. And you can see that a lot of these locations have only 1 year of monitoring observation. That's mean like just one data point. And this one data point is mostly like these new ReefCloud users. So we had an exponential number of users through the time. And that's what we call the from data to actions. Then people have access to this public dashboard when they have the latest information about the trends, how is it doing, about some information about disturbances as well. And then they can make decisions based on this information with this automatically updated. So what we have with ReefCloud then is like with these three components, we're able to scale the monitoring effort by including like various organizations. We're able to what we call with democratized knowledge. People have access to AI skills and statistical modeling, and then we can deliver like information at the right cadence because the changes are really fast. And we need to react fast as well. And looking at the global biodiversity framework, then these three components just meet like 9 targets of this framework. And so, thank you. So we have a lot of partners and a big team as well. I want to acknowledge the ReefCloud team. That cannot happen alone. And I have a surprise, it's like I had a chance to record a podcast with our chief scientist where we talk more about ReefCloud. So I'm sure like all of you have a long way back home. So if you want a bit of entertainment, don't hesitate to listen to the podcast. Thank you.
Well done, Julie.
Thank you.
That was lovely. I love the fact you really are communicating with people who actually contribute the data, and then you're much more likely to get more data. Brilliant.
Yeah.
David, do you want to come up? I don't know quite how we do the next slide.
You just have to click here.
Okay, fine. Well done.
Yeah.
Done. Prizes. Okay. David, thank you very much. Now, we will... can you be about 10 minutes?
If I go too long, you just start yelling at me, okay?
Okay, I will do.
I'll set myself a time, and then we should be as good as gold.
All right. Right, we'll take those two. Sorry. I think we've got some wonderful opportunities for some really interesting discussion. So, David, off you go.
Absolutely.
And you're local.
And I'm a local, yeah. All right. So this presentation is a little bit different from all of the ones that we've had previously. So I come from the University of Queensland, and today we'll be talking about cybercrime. But we're going to see a lot of parallels once we start talking about data. A lot of these things, they're pretty universal across disciplines, okay? So let's go and jump into things. Now, first of all, we're talking about cybercrime, and it's on the rise. Now, last year alone, worldwide, we lost $1 trillion just to scams, okay? Not to anything else in cybercrime, just scams alone. To go and put that in picture, that's greater than the GDP of 180 of the countries in the world, and it comes in number 19 out of all of the countries, all right? Just to go and scale that back for the Australian locals, if we took all of that money, we put it into the Australian economy, that would equate to $756 per person per week. For reference, for everybody else out there, that's 150% above our current poverty line, okay? Cybercrime's massive nowadays. In fact, cybercrime is so massive that it's directly leading to poverty, to modern slavery, to human trafficking, and disadvantaged communities. The effects of it, unfortunately, go a lot further than outside of the computer, and it really goes and damages the communities that it affects. These guys go and see the horror stories of people that lose their whole entire livelihoods just because of this single second, okay? Now, we're always going and striving for data-driven solutions to improve our health, our planet, our community. And so when we go and do that, why don't we focus a little bit more on cybercrime as well? Now, this next slide here, I'm actually going to go and skip over this one in the interest of time, because we'll keep on going with all of this. But we're going to go and talk about a couple of things during our presentation, okay? The first of these is that, well, we're all data people, and so we're going to be talking about the technologies that are going and assisting in apprehending cybercrime, and then the data-driven problems that we're going and experiencing with all of them, similar to, yeah. And then secondly, we're going to go and talk about governance for the people that have a little bit to do with United Nations and everything. This is going to seem straight at home. You're going to know exactly what we're talking about afterwards. But anyway, just as a really quick one, there's these two emerging technologies that are really driving changes in cybercrime. All right? Now, the first of them, yeah, Alison, I'm looking at you right here, is blockchain. Yeah. And it's actually, it was great to go and see that you're putting it to a good use, because blockchain technology, by the way, guys, incredible technology, okay? It's got these really good use cases. The one bad use case is when it comes to cryptocurrencies. People tend to think that like Bitcoin is just this massive gambling platform nowadays, but when it was created, it was really sinister. Back in 2012, 35% of transactions were actually related to drug marketplaces. Okay, that's where it began, and this is what it's become nowadays, but it really facilitates cybercrime as a good medium for going and sending transactions, because, well, it's pseudonymous. The second one is Gen AI. I don't really have to go and tell you this one, guys. Like, you guys have gone and seen all the horror stories that happen on the news where people go and lose their whole entire livelihoods because of scams that are facilitated through Gen AI. All right, so these two technologies, they're going and really driving change in it, and anti-crime infrastructures, we're really struggling to keep pace with the changes, sorry. Why is that happening? It's actually your problem right here. It's because we don't have available data. Okay? Now, when it comes to cybercrime, there is a real lack of data availability. Just punched that. There's a real lack of data availability, okay? And it's not that the data doesn't exist. For example, there's a lot of law enforcement that have it, but for very obvious reasons, they can't go and disclose all of this data. And because of that, we really go and rely on, well, there's a couple of few open source data sets, the largest which comes from the AIC, the Australian Institute of Criminology. But other than that, there's not too much to run off. We have to rely on monetized data sets or self-reported data sets, which is a problem because only about 30% of cybercrime incidents ever get reported. So we're really running on obsolete data. We don't have too much to go and work with, and the exact same problem like we were talking about before is that the lack of this open access data, it really makes it difficult to go and create these novel interventions for it. We're doing a little bit to go and change that, okay? On this next slide here, then this is an infographic that's more or less been ripped directly off the Australian government's website. Okay? And it basically goes and says that, like, hey, I've been scammed. What do? First of all, I contact these guys, and I go through the whole entire process, okay? Emphasis on I contact them for two main reasons. The first of these is that, obviously, it mitigates all of your risks when you've been hit by a cybercrime incident. But secondly, then we get to learn from this experience. Then that data is there, that self-reported data is there, so that these problems don't go and happen in the future. And it's not quite enough, obviously, but it's a really good starting point so that we can go and develop all of this data that, well, I'm preaching to the choir right here, we all know. We need these data-driven solutions in every single industry, and cybercrime is not just the only example. Unfortunately, for the time being, we can't really have technological solutions. It sucks to say as a computer scientist, but it's not going to be all the answer. Don't give me that look. No, unfortunately, we've got to go and look into other things. Okay? Now, as a really quick one for you guys, cybersecurity is built on three main pillars. Okay? People, processes, technology. Okay? We're doing the best that we can in technology, but we need to go into the legal infrastructures for it as well. And these things right here are actually phenomenal at going and making a difference in crime. Okay? As an example for you, Monero, which is a cryptocurrency, and it's long been associated with crime because it's basically untraceable, it's banned in Australia. That's something you can't achieve through technology. That was an actual regulation that went and got it in place, and it's just gone and killed it dead. Really goes and reduces it. It's incredibly helpful. Unfortunately, when it comes to regulation, there are a couple of issues. Okay? For anybody that's gone and worked in policy making, this is pretty familiar. First of all is that it's slow to implement and it really lacks scalability. Secondly, they have standardization issues between different nations and entities, and anyone that's ever gone and had to work with the UN, they know this one. But because of these issues, because it's really slow and it lacks scalability, then they have this really tenuous regulation of emerging technologies. Okay, blockchain and Gen AI, these are these things that have started going and coming out, but they're really difficult to go and regulate. All right? And so what's our solution for these ones? If it takes so long to go and build up all of these regulations for things that are in the present, then the best way to go and do it is to try and predict for the future, if this makes any sense. That's what this next slide is. Okay, to go and do this, then they rely on anticipatory policy making, anticipatory governance. 2 minutes left? Okay, we'll wrap it up. To go and predict for the future. Okay, really good example of this is Liechtenstein's TVTG Act, which essentially was a way of going and saying that, like, it appeared in about 2020 from memory, and it accounted not only for the blockchain technologies at the time, but it regulated any blockchain technology that would emerge in the future of it. Okay? It's a way of forecasting the future so that it can go and get the stuff all the way across. And in going and doing this, it makes many improvements over traditional policy-making strategies. Obviously, it's a proactive intervention. Okay? It doesn't go and put out the fires that appear in the moment, but it tries to go and predict for the future and cater for problems that are going to go and emerge later on. Because of this, it caters to a range of possible futures. And obviously, it allows it to have an early response to trends. But probably the most golden thing about it is that it uses a multi-stakeholder model. Okay, this is not made by people that go and sit in an ivory tower that have nothing to do with all of these things in the day-to-day field. This is gone and used by people that are involved in the area, and it's created by everybody. Now, Virginia's about to go and yell me off stage, so I'm going to get right to the end right here and go and say, to go and wrap things up, cybercrime is a massive issue, okay? And it's the sort of thing that we can't go and do through technology alone. To go and combat it effectively in the future, we need to go and create more scalable frameworks. We need to go and create more readily available data. And when we go and do that, then we can finally do our best to go and stop cybercrime, to help end our poverty, our modern slavery, our human trafficking, and our disadvantaged communities. Thank you so much for waiting there. Let's get on to the question time. I'm going to go and hand over the stage right now.
Well done, David. Can I ask all the questions to come up? Alison, Pedro, would you like to come up? Oh. As we go, Pedro, just take advantage of you. Julie? I'm not sure she's online still.
Oh, can we just exit out of this maybe, or how do we do this?
No, I don't think she is. Is she?
I'm not sure. How do we actually...
Okay, can I just say that I thought cybercrime was very much one of the points that Juliet brought up this morning. You were absolutely right. So well done. Thank you very much. Now, I think you've had some really wonderful presentations. What you've shown is that you cannot manage what you cannot measure. Again. So it's so depressing that you can't do it. So I think it's really important. Does anybody have a question that they'd like to raise just for clarity? No? Okay. So to me, let's have a little discussion about it. I thought the EMOD work you're doing is absolutely fascinating. The fact you're working across many river basins, sea basins, and all the different networks you have. That to me was something that's really important and a great success story for Chiara that you managed to do that.
Could I mention something on that?
Julie, I'm really thrilled that you are looking at getting communities to work with you, but cybercrime is a nightmare. Now, Alison, your paper was really interesting. I looked it up very easily on the web.
Oh, good.
Oh, nobody can hear us, sorry. I'm muttering to myself, how exciting.
Say it all again.
No, I won't.
All again.
No, we haven't got the time. We have about 5 minutes or so to be able to do this. So I just wondered, listening to all 5 of us speak, we've all done something a bit different. Would you like to point out, Alison, what you thought was most useful from one paper? Just one.
Just one. Most useful. I was just harking to what you said earlier when you weren't on the microphone, that all of this was based in some sort of data or the requirement of data. In your case, I happen to know about the Allen Coral Atlas. If you didn't have that, which took a lot of work, you couldn't have built the rest. So that was the mapping of and the sea bottom and everything. So, you got the data, then you could do then you could do the next stage. So I thought that was very exciting. Base of the data, but then the building of the decision making and the tools, and of course the community engagement. So there you go. Sorry.
From my point of view, my takeaway is, okay, we have data management system, we have collected data for citizen science, and then use them. Yeah. Use them, please.
I think you're right. It's a really good idea. Citizen science matters. Julie.
Yeah, I will talk, I guess, about the cybercrime. And I really hope, in the future, we're going to get more data, because it's just crazy that we cannot track. I have been hacked 2 times last year with Optus and Medibank, so here in Australia. And so it's just 2 times. And yeah, we didn't have any support either, or we just don't know what happened. They just say sorry, and that was it.
Yeah, and so sorry to hear that happen, by the way. It's unfortunately, those hacks affected a lot of people when they did happen. But the one thing that I go and take away from all of this is that, there is no one solution for any problem. It's all well and good for me as a computer scientist to just be we'll just throw an AI at it. That's going to solve that. But it's not as simple as that. I require all of this data, and to go and get all of this data, we really need to go and create these strong policies to help and enforce it. And when it comes to all of you guys, you guys know it as much as I do. As soon as we've got the policies that are in place, then suddenly we can go and reduce the waste for single-use plastic, and then we can start looking after our oceans. And it's not just from that, it's from the everyday communities. It's really, the world's got a lot of problems. The world's got a lot of problems, and unfortunately no one person can go and solve it. We really need to integrate all of our different skills and approach these things together, and then we can make a little bit of a dent in them.
Thank you. I think all 4 of you came up with brilliant comments. Really pleased. And I think, in fact, we are in the right panel. Nice to have a few more people. As Chiara said, I thought that was quite amazing. Is there any questions from the floor? There is one. Great. Do you want to come to us? Okay. Come and walk up. Do. It's easier. Could you come and join us? You just come, and then we won't feel quite so isolated. Can you just, you can't find them.
My question was for Julie. With your engagement with the custodians of the data, did you find new or interesting questions to ask of the data that informed your research? Or did you discover new questions from the local people that changed your research questions? Or
Thank you, Jessie. Yeah, we realized that working with the local communities, they're actually much more interested about the fish than the corals. So everything Reef Cloud is really based on detecting the corals and everything that live on the floors, but the local communities, they don't really care about this. They care about the fish. So, yeah. So, yeah, but I think it's because also they don't necessarily make the link that they are both related. The fish, they know that they use them to eat, whereas the corals, they don't even usually see them because they don't necessarily dive. So, yeah, maybe we're going to change the research questions and deviating a bit more for the fish, but it's going to be a massive challenge.
Any other questions from the floor? Yes, please come up. Hooray.
We do have a 3 more questions and we have a
Hi. That's Jesse. I'm Alex from QUT. It's a question for David about cybersecurity. It's more so about the how scammers also evolve with technology. So do you think that regulation is, because with the scammer, with the new AI feature, they can just immediately use it and they can pretend to be someone. Whereas if you are combating that, it's hard to go through the regulation, if that makes sense. Do you think regulation is something that's slowing down the combating against the emerging technologies? Does that make sense?
That's a fun question. Yeah. So I'm gonna go and steal this one. And yes. That's a really tough question, that one, because yes, you're dead right. At the end of the day, when it comes to cybercrime, these people are the first adopters for the technology, okay? Now, researchers are the people that go and come up with these really incredible, innovative strategies. The cybercriminals will be the first to go and adopt it, and then it goes and trickles down. Unfortunately, because of the way that regulations are usually gone and set up, that means that law enforcement, one of the people that go and get to utilize these technologies last. But that doesn't mean that it's a completely bad thing, and so that's why it's a bit of a yes and no sort of thing. When it comes to adopting the technologies, it's a little bit slower for them. But at the same sort of time, they can also utilize all of these regulations to go and make it a little bit more difficult for scammers, okay? 2 really good examples. The first of them was from the presentation, where it's like Monero, that massive cryptocurrency, always associated with criminal transactions, boom, illegal in Australia. But probably a bit of a more real one, because you're familiar with Gen AI, is that when they first went and came out, there was this really big problem of people utilizing it for all the wrong purposes. Like, for example, they'd ask the Gen AI, oh, how do I go and make explosives? How do I go and make this, that, and the other? All of these things that were really just horrendous, and it would just go and spit out the answer. Regulation stepped in. Okay, all these people with the policies, they said, no, we can't do that. And because of that, they've gone and done a really good patch on this technology so that it goes and mitigates all of that risk. So the short and nasty answer is you're completely right. But there's a little bit more to it as well. At the same time, it's a bit of a double-edged sword, because it really goes and does a lot of good things at the same time.
Thank you very much.
Any final question from somebody else? Yes. Lovely. Our helper. Hooray! Oh, good news. Can we have your name, please?
Hello, I'm Kirti. I'm from UQ. I'm a volunteer here. So first of all, really amazing platforms and initiatives from everyone in the panel. My question is to Julie again. So, so first of all, Reef Cloud is a really amazing platform. I am also working in water quality forecasting around the Great Barrier Reef region, and I totally understand all the problems that you're trying to say right now. One of the things that I want, more of a clarification, I would say, the thing is, I really love the fact that you had the whole like explanation point of view in like normal English for like people who don't understand the technology most probably. But then I also wanted to clarify, does that also include all the classification algorithms and the feature importance and how it exactly classifies the data into like according to the coral health chart, I assume? So because I've looked at a lot of reports and it is very like technical jargon. So yeah.
Make it understandable. Crystal clear. Is that right?
So I'm the statisticians in the project, so I'm not doing the ML, I'm not doing the machine learning algorithms, but it's part of the report as well. So when you're happy with the data, then you download the report. But there is not necessarily a lack of really high explanations about the ML, and mostly because we have the papers that are published. So we just cite these papers, and if the people, they need more explanations, then they go to the papers. But we have the support and the support teams, and we all work together. So sometimes, two times, we have like high technical questions, and then we redirect straight away to the experts.
Well done, Judy. Now, one last request from our three who haven't asked a question. Do you want to ask a question? Come on up, come on up. Because we're going to overrun a bit, do you mind? Because I thought your papers were just brilliant, by the way. Thank you so much.
Thank you very much. My name is Alex, I'm from AIMS, I'm Julie's colleague. I deal with those MLs and DLs that are that crunch the data that we have there. But my question is for Alison. Actually, it's not a question. When I heard that you'll be using blockchain to secure data exchanged between organizations in the Pacific or governments in the Pacific, I kind of asked myself, why is that necessary? Blockchain is a technology that secures transactions normally, so it uses cryptography to ensure that the transaction is what it really is. And in this case, and I know from personal experience that Pacific governments, they generally share data that's not at that security level. They don't share financial data normally. They what they make available on Pacific Data Hub or on SPREP's portal, I keep forgetting the name, is normally data about, I don't know, not even about fish, for example. That data is considered quite secret. So is the blockchain really needed in this case, or it's just something that will secure security of the data in the future? Thanks.
Thanks very much. Quick question, quick response, Alison. Quick this time.
This time? Was I long the previous time? Did it take a long time? No, I don't know. Oh, yes, but so I was exploiting the moment. Maybe, but do note that the data that they have now is beginning. They're only just beginning to, they're not sharing, they are sharing data, they are monitoring fish data, for example, but they had nowhere to put it and they didn't know how to put it. So to put the security tags on was really important. So that was one of the reasons why someone in our group said, hey, blockchain could do this if we kept it private. So that was why.
I think we've had the most amazing discussions, and I think we've all laughed and enjoyed it enormously. And I think the work that you're doing in Europe is incredible, and your plea for it, and for more people to know, Chiara, you're right, but actually we all need to know, and I think this is a really good session. We could turn it into a peer-reviewed paper if you wanted. Do you want to do that? Let's all contribute to a paper. If that would be a way to try and show that we need to do something about it. So if you're all here for the next day or so, shall we just try and write a paper on the side? Because I don't think that let's tell them another way. If they won't come, we'll tell them. I know. So I just think it's hilarious, but data matters. So to me, I really want to say a huge thanks to you. Thank you for sharing us so beautifully at the beginning. But I also wanted to say our global hazards list is there for you to use. Eutrophication is in there. Coral bleaching is in there. Cybersecurity is in there. All the things you talked about is in there. Use it so that we have a common language to try and make sure we deal with it. And by the way, climate change is a driver of hazards. We couldn't get it in as a hazard. And AI, it's a driver too. It can be good, but it can be bad. We know that. Did you want to say a final something? But we can also write a paper. Shall we get everybody up here? All of you, come and join us. Audience, come on.
I mean, all the audience.
We just need all of you. Come on.
All of you.
Will you come and join us, please?
I like to volunteer. And we will, I will share my email list.
Thank you for the It's got the things in there.
So all
use it. We'll work together.
Yes, we together.
Do we get out of the sector?
Can we turn off?
Go that side.
Can we turn it off?
Yes, because you're talking.
It's good to have a... Okay.
Please, together.
Oh, that's the right way to do it.
Yeah.
You're too tall.
Oh, good. Thank you. It's okay?
Yeah. Okay, working group.
Please.